we have our next topic, which is the stoichiometry. So calculation of amount of substance in the reactant or in the product based on the balanced chemical reaction by ratio and proportion. This is actually more on balancing of the elements. So let's move on to the an example so that you will be able to appreciate more the definition of stoichiometry. So for number one, we have a caustic soda, NaOH, is made from sodium carbonate Na2CO3, and a lime, CaOH2. So how many pounds of caustic soda can be made from 2,000 pounds of sodium carbonate? So this is what happens here. So we have here the givens again. So we have given is um we have Na2, right? So okay, NaCO3, and then plus the lime, which is CaOH2. So this should be equal to the caustic soda, which is NaOH. So NaOH. Okay. But we have to add here to make the um, equation balance. Okay. So you will add here, since as you can see on the left side we have a calcium, right? So Ca, and we also have a carbon, so CaC, and then we only have one oxygen here, and we have three oxygen on the left side, and then another. We only have one oxygen here, and we still have three oxygen here. Therefore, we already have one oxygen here, so we can add here another three to make the um, equation balance. And then next, we have to balance this more, because what happens here is you first balance all the elements other than the oxygen and hydrogen. Okay, so as you can see, the Na, okay, and then the calcium and the carbon are already balanced. So what happens here is, no, this should be Na2. Okay, Na2. So as you can see, that we have to still balance the oxygen and the hydrogen. So if you want to balance this, therefore you have Na2CO3 plus calcium OH2 equal to, we have two Na on the left side, okay? OH plus CaCO3. We have two Na on the left side, and then if you count all the hydrogen, no, the oxygen, we have four on the right side, and then we have how many on the left side? We have five. So we're still lacking another oxygen here, and then for the hydrogen there are two. So we're still lacking another hydrogen here. So to make it balance, we can just put here two. Okay. So you'll in this case you have two Na, two oxygen, and two hydrogen. Therefore, that is already balanced. So what happens here is you have to get now the molecular weight of Na2CO3, and then times 2, right? Times 2 of the molecular weight of NaOH. Okay? So setting up the ratio and proportion, we have 2,000 pounds of sodium carbonate. Okay? 2,000 pounds of sodium carbonate. So sodium carbonate is molecular weight of Na2CO3. This must be equal to the X of the caustic soda, but you have to times 2 of the molecular weight of NaOH. There you go. So first off, we have to get the molecular weights. Okay, so getting the molecular weights of Na2CO3. Okay. Molecular weights of Na2 CO3 is equal to, do we have some givens? 23. Na is equal to 23. So we have 2 times 23 plus carbon. I think carbon is 12. 12 and then oxygen times 1 only plus 3 times 6 is equal to 106. And then for the molecular weight of NaOH, that is 1 times 23 plus 1 times 16 and then plus 1 times 1 for the hydrogen. So this is just equal to, how much is this one? So 6. This is 40. Those are gram per mole. Okay. So setting up again, so you just have your 2000 over the molecular weight of sodium carbonate is 106 equal to x. Don't forget that this is 2 times 40. Therefore, x is equal to 1504.43 pounds. Okay. So this will be your answer. Okay, let's just write this. Therefore, x is equal to 1503. No, 4.43 pounds. And this will be your answer. Okay, so let's move on to the next number. Okay, so for number 2, we have the execution manager of the lethal gas chamber in the state of penitentiary adds excess dilute sulfuric acid of H2SO4 to 196 grams of sodium cyanide NaCN. So what volume of HCN is formed at STP in liters? So we are given with atomic weight. So what happens here is we have NaCN, right? And then plus H2SO4. And then we are asked to find what volume of HCN. So again, we have to somehow balance this one. So you can see on the left side, we have Na. So we don't have any Na on the right side. So let's add Na here. And then SO4, right? Okay, we add here again. SO. Okay. And then we have to balance this one because as you can see, this is not yet balanced because of the number of balance of number of hydrogen. So NaCN plus H2SO4 equal to HCN plus NaSO4. Okay. So balancing this one is you first balance the hydrogen. So on the left side we have 2 hydrogen. So we only have 1 hydrogen here. So let's make it 2 here. So now we have 2 hydrogen. So the hydrogen is already balanced. But we now we have 2 carbon and 2 nitrogen. So on the left side we only have 1. So 1 on of each. So you put here 2. But now the Na is no longer balanced. Okay, so this should be Na2. Okay. So this should be Na2. The one that we'll be adding here should be Na2. Okay, so that's already balanced. Therefore, you'll have here 2 times the molecular weight of NaCN, right, is equal to 2 times of molecular weight of HCN. So these are the two that we must be looking for. So applying by ratio and proportion, you'll have here the mass of 196. Mass of NaCN is 196 grams, right, over the molecular weight of NaCN times 2, okay, times 2 is equal to X. This is the one that we're looking for. Volume. Okay. So volume, when you say volume, it should be the mass also. Okay, in this case, because the given is mass, therefore this should be also a mass. So this is 2 times the molecular weight of HCN. Okay, so let's find the molecular weight of NaCN first. Okay. So for Na is 23. So 1 times 23 for carbon, that is 12, right? Yeah. 12, 1 times 12. And then for nitrogen is, I think it's 14. Yeah, 14. Plus 1 times 14. Okay. And then for the molecular weight of the HCN, hydrogen is 1. And then carbon is 12. Nitrogen is 14. 1 time. So this is actually 14, 9. And then we just and this one. Okay. So this will be 196 times 2 of the NaCN. So that's 49 equal to x over 2 times 24. And then if you find the value of x, so 108 grams of HCN. So this is the answer. Okay, so let's move on to the next topic.